So now in this case, you have to solve for this. You have to find all the values of x for which your fx is greater than this. So this is the condition. The domain has been specified. Now the angle here that we are dealing with is x by 2. So you have to change the domain so that we divide throughout by 2, and you have to look at all the solutions. You divide throughout by 2.
Yeah.
So, correct? 3 times. Good. So now what you want is, you can first begin with saying that let fx be equal to that. Then we'll see what to do with the grade.
It's easier to do it like that.
Yeah, it's easier to put equal to start, get the zeros, get the solutions, and then we can work further with that. We'll see what to do. I'll tell you what to do.
Okay.
Is equal to 2 root 2 plus 1. So plus 1 cancels. So cos x by 2 is equal to 2 root 2 over 4.
Which is basically
1 by root 2.
Yeah.
Correct? Now 2 root 2 by 2.
Yeah.
So that's your pi by 4.
Yeah.
But now look at my domain. So what I have to do is, I have to strategize. So this is your 0. Correct? Pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2.
Yeah.
That means we have to look at all the, you have to look at my domain is from here, and back here.
Correct.
You're looking at 1.5 circles. So you have to look at all the angles that come within that.
Yeah.
Now the base angle here is pi by 4, 45 degrees.
Yeah.
So pi by 4, so I have to look at all the pi, so I have to look at all silver teacups. I have to see where it is positive, because it's plus 1 by root 2. So I have to look at here, and I have to look at here. Correct? Which my angle being at pi by 4. Correct? These angles are, the base angle is pi by 4. Now let's look at the solution. So let's start. My first solution, I'll start from here. My first solution is pi by 4.
Yeah.
My second solution is, so first solution, so x by 2 is equal to first solution is pi by 4.
Yeah.
That's my first solution. Second solution, you come all the way here. So that's 2 pi minus pi by 4.
I can't even raise the users.
Alright, 2 pi is a full circle. Huh?
Oh yeah.
You're falling short of, you're falling short of a circle.
Yeah.
You're falling short of pi by 4. Ajay, the next solution again, third is again here. What is my third solution?
The third solution would be
2 pi plus pi by 4. 2 pi plus pi by 4.
Yeah.
So that means these are my solutions. I have simplified. So x by 2 is equal to pi by 4. 4 2s are 8 minus 1, 7 pi by 4. 4 2s are 8 plus 1, 9 pi by 4. You cross multiply.
So now you find x.
Now you find x. So x is equal to 2 pi by 4, comma 7, 2 pi by 4, correct? Comma 9 pi by 4, correct? So x is equal to pi by 2, 7 pi by 2, correct? Because this will, yeah?
Yeah.
And 9 pi by 2.
Okay.
Okay, these are my solutions. Now I don't just want the solution. I got the answers now. I got the intersections. Now I want when fx is greater than this.
Oh yeah.
Now that's where the catch is. Try it out. Let's see.
What did you try to do that?
No, okay. Let me give you a hint. Let me give you a hint. Can you sketch a graph for this?
Yeah.
Can you sketch a graph for fx?
Graph, and you put dilation 4.
Correct. Period. So dilation is 4. Or stretch factors. There's a vertical stretch factor. Vertical stretch is 4. Which means your amplitude is 4.
Yeah.
Correct. What's the period?
X by 2.
2 pi.
Alright.
Divide by b.
My bad. Alright.
2 pi upon b.
Yeah.
So 4 pi is the period.
Yeah.
That means this is my cos graph. Correct. This is 0. 2 pi. 4 pi. I have to go till 6 pi.
Yeah.
6 pi. Amplitude is 4. Correct?
Yeah.
This is minus 4. So that means my graph that I'll be drawing. The period is 4 pi. 4 pi, one cycle. One entire cycle comes with 4 pi.
So a crescent and drop.
Yeah, well, it's a cos graph, so it will be like this.
Yeah.
And then you complete this, obviously.
If there was an x over 2, we would just forecast x plus 1.
The period would be pi, 2 pi.
But then if you do then what period, say, okay, you just do raw cost graph and just multiply all the values into y values before and x values.
Yeah. Now, yeah, you can do that. Yeah. Now, what is going to happen is we forgot the plus one. What does the plus one do?
Horizontal stretch one.
Vertical.
Sorry, vertical stretch.
It must
Vertical
translate
stretch,
vertically up.
vertical transition one up.
Vertical translation one up. But anyway, you can ignore that
Why?
because if I'm looking at, I'm looking at this
Yeah.
because one and one cancels off.
Oh, so anyways, it's not there.
So it's anyway, you can look at that and get the solutions from
Yeah,
that.
yeah.
So because one and one is now, how do you get root 2? What is the value of root 2?
What's the value of root 2?
Approximately 1.4.
How do you know?
So 2 point, I mean, it's okay. So some value is there root 2. Some value is there root 2. 2 root 2 is some value, let's say 2 root 2 some value. What we have is, we have the solutions. These are the solutions. This is where the graph is meeting.
Yeah.
So that means this value, we know this value is what?
X over
Pi by 2. This value is what? 7 pi by 2.
And
This value is what? 9 pi by 2. Now you have to see
what fits within it.
where the function is above this.
Oh.
So function is above this from here to here.
So the fx is here, it's above the thing.
Yeah, the function is above that line. So you're checking where the function is above the line. Here and here.
Yeah.
Are you following that? Plus one cancelled off.
So yeah. So 0.
So function is above 2 root 2.
So when you factorize x is actually value.
So what will that be? 0 is less than x is less than pi by 2. Correct?
Yeah. And
Or
7
pi by 2 is less than x is less than 9 pi by 2.
So they don't want ranges. They don't want actual values.
The range of values will get. Whenever you solve inequality for such sums, you'll get a range of values. So that's your answer. That's how we do it. Important sum. Okay. Now this is an important sum. The first part you got correctly. So let me do it over here for completion of this page. Okay. So what you have to do is your fx basically is the intersection. Fx is equal to minus 1. So fx is equal to 2 sin x is equal to minus 1, and my domain is, of course, has been given as this. Correct?
Yeah.
So sin x is equal to minus half. So if you look at all silver teacups,
Negative in third and fourth quadrant.
Negative in the third and the fourth quadrant. And your base angle is what?
30.
No, pi by 6.
Yeah, same thing.
Think in terms of radians.
Okay.
So that means my first answer will be when you come here. So pi plus pi by 6. Correct?
Yeah.
The next one will be when you come from here to here. 2 pi minus pi by 6.
Yeah.
Correct? So x is equal to 7 pi by 6 and 11 pi by 6.
That's good, but yeah.
So that means the x coordinate of A, this is your A and this is your B. Correct? Now consider another function gx is 2 sine px for the same domain. So your p is what is p? Is the horizontal stretch factor.
How?
You forgot? Functions.
Yeah.
So what is the horizontal stretch factor?
P.
No.
Wait.
1 upon p.
Oh yeah. Okay.
Horizontal 1 over p is the horizontal stretch factor. Now what you have to do is, basically you want your g in such a way, you want the period of g to be in such a way that this intersection should go beyond 2 pi. You want to adjust your p in such a way, so this is my graph of g.
Yeah.
So that my answer should not come in the domain. They're saying that does not intersect.
Yeah.
Does not intersect in the domain.
Correct. Okay.
It does not intersect means your graph has to be something like this. That means what is the first where will it intersect? When your a dash is at basically at 2 pi.
Yeah.
Beyond that it won't intersect.
No.
That means I have to take the x coordinate of A.
It's greater than 2 pi.
I stretch it.
Oh.
I take the x coordinate of A. I stretch it so that stretch it in such a way that it's greater than 2 pi.
Yeah.
Correct? Stretch it so that it's beyond 2 pi. I'm stretching that till it's beyond 2 pi basically. So then you solve for, so you obviously, to make it easier, you take it equal to this, because you know to be solve for p basically. So 7 pi is equal to cross multiply 6, correct?
Yeah.
Pi cancels. So what's the value of p?
7.
It's a very important
You
subject.
don't only for one, like, could you get the same answer?
But yeah, if your a doesn't come, b obviously
I
won't come.
have one question.
Yeah.
Why, sorry, this is dumb, but why, I get that 1 over p is your horizontal stretch, but why you like applying the horizontal stretch of 1 over p to your a and b? I don't understand why I'm doing
Okay, I'm doing that because anyway, when you stretch the graph, your a will also get stretched. No?
Oh yeah, see because
A dash is lying on the graph. It's a good question actually. It's a good question.
Yeah.
So rather than applying to the graph, I'm applying on the coordinate of A, because the
to
point A lies on F, your point A dash will lie on G.
So that changes, yeah.
That changes.
And
Correct.
then apply to that
Correct.
gx.
Correct. See, what you've been given, the following diagram shows a right angle triangle ABC.
Yeah.
D lies on AB such that CD bisects the angle.
Yeah.
Correct. ACD is theta. AC is 14 centimeters. It's given over there. AC is 14 centimeters. That's a ratio.
Oh.
That's a ratio. Remember that. So your sine, given that sine theta is equal to 3 upon 5, correct?
So
Find the value of,
this is correct with this.
find the value of cos theta. That's right. That's right for that. So what you can do is sine is equal to, if you're looking at this right angle triangle, sine is equal to opposite side upon hypotenuse. Correct? You can just, it's a ratio. Remember that.
Yeah.
We should call it 3x 5x. We don't do that.
Yeah, because I was thinking that's it.
Yeah, that's a ratio. That's a length. So now if you want to do, so use Pythagoras theorem. So 5 square is equal. So don't get confused with the ratio. Are you following that? So what you can do is you can draw a different ratio triangle only. To avoid confusion, you're doing a triangle that deals only with ratio.
Yeah. If they say theta is 3 over 5, then it's actually that's the length.
So 3 over 5. So the actual length is not 4. The actual length is not, it's a ratio is.
But this is correct.
Yeah, what you did is right.
No,
I said it again. No? I said it once, it's correct.
I did the same thing, you change 4 to 14.
So 3, 5, correct? Then it's right. Then you can call it x. So 3 square plus x square. So x is equal to 4. So your cos theta is equal to 4 upon 5. Adjacent over hypotenuse. So now this is 4. So adjacent upon hypotenuse.
So BC is 50.
Now part B, cos 2 theta is 1 minus 2 sin square theta.
That's what I did.
You can apply the double angle.
You can use cos square theta, but you don't know if your cos square or cos theta is correct.
Correct. Very good. Yes. Yes. 9 over 25. So 25 minus 18, correct? Upon 25. That's how much? 7 over 25.
That's what I got earlier.
7 over 25 is your part B. I'm talking.
Yeah, I got that. Yeah, I got that. Correct.
Now, hence or otherwise find BC. So if you're finding BC, you have to use the entire triangle.
Cos 2 theta is equal to AC.
So entire triangle means this angle would be 2 theta.
Yeah, so cos 2 theta is equal to AC over BC.
So cos 2 theta is equal to 14, correct? Now you use
over
14
BC.
over BC. And cos 2 theta value we got 7 over 25
yeah, I got
is equal to 14 over BC. So if you work this out, BC will be how much? 50 centimeters.
Yeah, I got it. So be careful with the ratio.